So this is problem number 10 on the Chapter 7 review, and it is a depreciation issue. You buy a new car for $22,500, so I'll write that down here, $22,500. And the value of the car depreciates by 25% every single year. And I want to write an exponential decay model giving the car's value after t years. Well, right up here I wrote the formula that we're going to use. And you'll notice that the difference between this and the compound interest formula that we use is that instead of a plus r, we have a minus r. So just to work this problem out, the amount that we're going to have left, or the value, if you could call it v, the amount is equal to 22,500 times 1 minus 25% to the t, and our t is, well, t years. So we just put a t there. They just say t years. Now notice, this is an exponential decay model. And it's an exponential decay model because right here, our b, our base, is less than 1. So you remember, if we have a base that is less than 1, then anything we take it as an exponent to is going to be a decay model. So just to kind of work this one out, what is the value of the car after 3 years? Well, I'm going to change my t to 3, so I have 22,500, sorry for the comma, times, I'll just call this 0.75 because 1 minus 25% to the third. I paused there for just a second to get the calculator up, and I also put the formula right in there. I put in 22,500 to 0.75 caret 3, and I'm going to push enter, and I get 9,000, whoops, got it back to pen, 9,492.19, which is in fact my answer. Then the next part of this problem says, in approximately how many years is the car worth $5,300? So I know that my A is going to be $5,300. So that is equal to 22,500. I pushed the wrong button. 22,500 times 0.75 to the t, and I have to solve for t. Well, how am I going to do that? Because my t is up here as an exponent. Well, if I want to get an exponent down off of being an exponent and down into the base, well, first thing I'm going to do is I'm going to divide both sides of this equation by 22.5, so I can kind of get it a little bit more simplified. So I'm going to divide that by 22.5. And then I will have, let's work the numbers over here. I will have 5,300 divided by 22,500. That gives me that number, 0.2355. So that number is equal to 0.75 t. Well, let's call that 0.2356. I am going to take a log of both sides. I'm going to take a log of that, and I'm going to take a log of that. There's a decimal point right there. I can do that as long as I do it to both sides. This log right here will give me a number, which I'm going to figure out in just a minute. But this log over here now lets me change this to t times log 0.75. So what I'm going to end up with is I'm going to have a number log of 0.2356, and that's going to be divided by my number log of 0.75, and that is going to equal t. So let's find out what those numbers work out to be. So log of that number right there, in parentheses, is equal to that, negative 0.6279. And log of 0.75 is equal to that number there. So now I want to divide those two numbers. That number divided by this number, and I press enter, and I find that t is equal to approximately, let's make it approximately, 5 years. So it takes me about 5 years for this car to depreciate to $5,300. The key elements here: if I have my variable as an exponent, the way to get it down is to take a log of both sides. The other thing that I want to really emphasize here is I know that I have a log something over a log something else. That is different than when we are when we're doing log x minus log b, which is equal to log x divided by b. It's different because my log 0.75 is a real number and my log 0.2356 is a real number, and I'm just using them in this format over here to show you how the equation would work. But I could have transformed that into the negative 0.1249 number, and I could have transformed this over here into the negative 0.6279 number, and we would have had the same result.